Okay, this is the trig identity problem from James Stewart pre-calculus textbook, and basically it's trying to ask if f is sine, then you have to prove this equation. I'll write it out really quickly. Now it looks kind of big, but I'll go through it really slow. So we're going to start with the left hand side. We know f is sine, right? So we can rewrite it as this. Now, if you've been learning your trig identity stuff, then you'll recognize this as the addition formula for sine, which if you don't know, I'll just write it out real quick. So you can probably recognize it here, right? Sine x plus h, sine s plus t is the same thing. So we can write sine x plus h as this big thing here. Sine x times cosine h plus cosine x times sine h. And we can substitute it into the equation. So this becomes this. And I wrote the thing we substituted in red, so maybe you can see it a bit clearer. Alright, I've made some space. Alright, once we've reached this position, there's not much that's obvious that we can do right away. But if you wrote it like this, so basically just some swapping around, we can actually factorize this part. And when we factor out the sign, it looks like this. So now you can see we're getting somewhere, right? Now, if you're not writing this down and you're just watching the video, if you forgot what we're trying to prove, we're basically trying to prove this. So our goal is to go from this thing to this thing. And we're very, very close. Now from here, we're going to split the fraction into two parts. And you can do this because if you added these fractions back up, they would have the same answer. It would go back to this thing up here. Now you can split a fraction pretty much whenever you want, as long as the denominator is the same. Now we're going to move our maths up this way. We'll start with this left side part. We can rewrite this section as just sine x multiplied by cosine minus 1 over h. Now let's try this side. So cosine x sine h over h, if you factor out the cosine, it becomes cosine x times sine h over h. And now, once you put everything together, you get the answer you were looking for. So we just proved this trig identity.